Here we are with another video for the Revox A77. So what do we have now? As you can see here, just let me focus, okay. Here, this is a normal speed machine, okay, and I always thought if there was a reliable way to convert this to high speed. So 15 inches per second. If you look my video here, you will notice that I once made a bulky way to increase the diameter of this shaft here, and with the addition of vari speed I could achieve 15 inches per second. But that was a bulky way of doing it. It was not very reliable. It might had more wow on it, and okay. The good thing about it is that it was reversible, but it was a bulky way, not a reliable way. I thought, I kept on thinking about a way to do it more professionally. The first thing to think for this conversion is to buy a motor that is original high speed, but I couldn't find many of these on eBay. And if I found some, they were really expensive, and I thought it's not worth it to pay that money. The second way would be to find only the shaft, the capstan shaft here, to find only this and find an original high-speed one. But not only there were not many of them, and they were also expensive. I don't blame the sellers for selling it expensive, because it's a spare that has a demand and not enough supply. I would do the same maybe if I had one. We live in a demand and supply world, and that's how it works. Anyway, if you buy only the shaft, then the problem is that, here let me show you, that increasing the diameter of this, the diameter goes way down here, the tape goes way down and doesn't pass through this guide here, it passes under the guide, and it can easily slip out. First problem is that, and second problem is that because it's so down, it doesn't make good contact with the head here. So the original motor has some different positions for the screws on the cell here, and normally the original high-speed motor is a little bit higher. It's a little bit to the top, so that when this diameter is bigger, the tape remains to the same path. So if somebody tries to change this shaft only but not the motor, he has to modify the holes for the screws of the motor, this motor, to make it rest a little bit higher to make the conversion. I thought to do this conversion also, but I was afraid, because this is a working machine and I didn't want to risk damaging it. What I did so is that, here we are, I bought another motor. There it is. It's a working motor, but it is a normal speed motor, as you can see here. And as you can see also, the screws here, the holes are in the middle. When the holes are in the middle, it means that it's a normal speed motor. I think the motor is like that inside the machine, and normally the high-speed motor is a little bit higher, so these screws are a little bit lower here. a little bit lower here, here and here. They are a little bit to the bottom, so that when you screw it on the machine, the motor goes a little bit to the top. So I have to modify the screws also, but I have to modify the shaft somehow. What I thought is that I could go to a store and try to find a sleeve and put the sleeve. I think this is a part of this sensor. It's broken. Anyway, I will glue it back. So I thought I would just take the shaft out and go to a machine place and make a metal sleeve that will go on top of this. This is 4.5 millimeters, and I could make a sleeve with inner diameter 4.5 millimeters, outer diameter 9 millimeters, and length, this length, which is about 1.2 centimeters, this length. So I thought I can go and I could go to a store, give him this, give to the person there this shaft, and tell him to make a sleeve with 9 millimeters outer diameter, so that he makes this shaft for me. And that's what I'm going to do. So let me show you. This shaft can be taken out really easily on this motor. You just have to pull this safe like that, pull it out, just like that, and then after you do that, you just pull it out through the front, and that's it. So this is the shaft of the motor. This thing I'm gonna give it to the store and ask him to put a sleeve here and make the diameter of this 9 millimeters, and let's see how this goes. So in order to take out the motor, you should reach this stage. There are many videos documenting how to reach that point. I've done my videos in my channel also. So the top cover here, the bottom cover here, the back cover here, this cover here that holds the cards in position, and you have to take all the cards to make room here to work on the motor. Then the motor has 4 screws. Here it's 1, 2, 3 here and 4 here. You have to take them out, and you have to unscrew these cables here from the motor, and then the whole motor you will be able to pull it out. Okay, I will now do that and I will come back. Notice that you have this, which are the cables for the motor? These two cables are the cables for the sensor, and then these 3 cables, okay, these 3 here, they are the ones that give power to the motor. So you have to take a picture of these to know where to put them when you put the other motor in. That's all. So these are all the stuff after the modifications I had to do. This is the shaft. I don't know if you can see. I have to check the camera. Okay. I don't know if you can see how it is done. It is a brass cylinder that is pressed above, and that's how it's made. I had to send it to the workshop twice, 2 times, because the first time that was not constructed very properly. It was a little bit wobbly. I told the man there that that diameter is not very important. You can adjust it so it doesn't have to be very accurate. But the center must be very accurate, otherwise you will have wow. And the first attempt, I think the man didn't pay too much attention on that. He didn't know what it was for anyway. So it was a little bit wobbly, that part here, as you can see on the video now. So I took it there again, and the second time I think it's okay. Okay. So here we have the flywheel of the motor. Here we have the shaft. This is the motor, and here this is the shape of the motor that goes there. Here I have many kinds of nuts and bolts. It's 4 millimeters diameter, but with lengths of 40, 50, 60 and 80, so that I see which one suits my needs. Okay, let's go to the motor. As you can see, I have made some modification there on the holes. Let me show you. I did that modification with normal hand tools, as you see there. Here they are. Okay. And I didn't do it very correctly because, as you might be able to see, the damage is more than it should. Actually, I'm also learning. It's the first time I'm doing this. The first time I saw the picture on the internet, I misunderstood the picture because of the perspective of it, and I thought that the holes should be a little bit on this line from the center, all the holes, and I did that, and then I realized that I was wrong, and I drilled. I tried to enlarge the hole to this direction, to make it to make it sit properly, the motor, and this is the result of it. I know the damage is more than it should, so the holes should be like that on this line and to the bottom, and maybe a little bit that side to keep the shaft a little bit away from a nearby washer, from a nearby tape guide. I will show you that. So that's all. Here I have some oil. This is the proper oil. It's the DTE oil. Yeah, right. Anyway, so in order to close this motor, you just have to apply some oil here, okay, and some oil on this door. Then you just have to apply some oil here, which is where the shaft rotates, and some oil here. And you can do here just a little bit, just to make it slide in, but it's not that important. And then you just slide the shaft inside, just like that. That's it. And then you can see that the shaft came out this way here. I have to go and bring some paper to clean the oil came out. Okay, I had to go and bring some paper to wipe out the excess oil that might have come out here. Okay, and also here. Okay, I think that is okay now. Then I will slide this rotor in. I have to align the straight part here between two holes, and then I will put this just like that and just push it in the groove that it has on the back there. Let's see. Oh yeah. Let's see. Let me just guide it in the groove, because it doesn't always want to stay inside. And I think that is okay, as you can see. Slides perfectly and very easily. I think this is okay. Now, just wash away the excess oil here and maybe here. And this motor is ready to be installed into the machine. Okay, I'm stopping now the video, and I will put the machine on here and start the video again. Okay, this is the machine which is ready to receive the motor. We will need a normal screwdriver. We will need some sort of pliers so that we can keep the nut from behind. And here is the motor. At first, I think as the top of the machine is here and the bottom is here. Okay, so I think that the right side of the machine, this here, the bolts should be not 50. Do I have? No, that should be 40 millimeters long, these ones here. And I will use a washer also from the front. So let me put it here. There's a metal plate from this side, so you will have to move it until it reaches the hole. And let's take another 40, and we have ready the two bolts from this side. I think they are enough. Okay. The other holes, the bottom holes, will have to hold a cable here, so they will have to be longer. I think 60 would be the right length. Let's see. One goes here, and one goes here. Okay, that's it. Now I will try and put the motor. The motor should go like that. First, you have to guide these wires here behind behind the cooler of the speed control board and guide them on top of it, just like that. And then we should try and put all the bolts that we had before and put them and put the holes of the motor on them. Let's see. Oh no, I'm holding the wrong bolt. Let's see. There it is. I did a mistake. The first bolts that I used were not long enough. I think these two here. I used 40, yeah, but I should use 50. Definitely, I should use 50. So I will take two bolts here, 50 millimeters long, and I'll put them in. One here and one here. Again, guiding the wires on top of the cooler and try not to put the motor on a cable. There might be various cables here, okay? And then you have to move away the pinch roller arm, otherwise you will press it from the top and you might damage it, so be careful with that. That was all. Okay, seems to be okay. I will now check these parts here, that part which is the distance where the cables here are held, and see if the bolt is long enough. The bolt seems to be short. So the two bottom bolts I think I used 60, didn't I? So I will use 80. I will use 80 millimeters long. Maybe that's too much, but there is nothing there behind the motor, so there is no problem using this. And another 80 right here. Take a washer and put it in. Take out the old and put in the new. Okay. Now I will fix the nuts one by one, and I will at the same time hold the motor as much to the top as possible, because that's where it should sit. I will do it now. I will just put another washer and a nut on the back side, and I will start the video again to show you exactly how it became. So everything is finished, and this is what I did. As you can see here, I used double nuts there, and back there. Okay, I used the two of them just for the second to secure the first a little bit more, and I put washers on all four bolts there, and then I just used another nut to secure the cables here and here. And let's see from the front what we have. So the four screws holding the motor is this 1, 2, 3, there, and 4, which is there again. Now, I don't know if you can see, but now the motor is a little bit more to this direction, so that it stays away from this tape guide and makes the tape go again that way, go again like that before, because if I wouldn't do that to the motor, the tape would be like that, because this, because of the increased diameter, would be way too low that direction. Okay. Here, as you can see, it sits perfectly. And now I will close the machine and test it. What I did here, remember, this is the treble control mode that I did for this machine, and these here are the original resistors the machine had, and this was to keep the treble adjustment as normal and just increase it without decrease. Now I will take out these two resistors, and the reason is because I will not adjust the equalization of the machine during recording. Maybe I will do it in the future, I'm not sure. I will, or maybe I will not. But as the machine will become more responsive to high frequencies because of the higher speed, I can with this then lower the treble and make the equalization correct, but this way I will lower the hissing also, and I think that would be worth a try to do it. If I think that the recordings are too tiny with too high frequencies, I will adjust. The boards are not here. There are here adjustments. If I take the boards are there waiting. If I take the boards and put them there, and put them on the correct position, there are equalization adjustments where I can easily reduce high frequency response to make it exactly flat for the high speed machine. The service manual has some differences on the boards for a normal and high speed machine, which are here, but I don't think I will bother do all these changes, because I think you can just adjust the equalization from these. I think, is this the bias? This is the bias from these here. So that's it. I will now put a tape and make the first test on the machine. So here it is, the machine after the modification, and the tape seems to run perfectly in the guide. I'm happy with it. There is only a minor problem, and this is the bouncing of the tape at the beginning. You can see it here. I think this is because of the conversion to high speed, because normally the machine compensates for that. It's this capacitor here is charged, and when you press play, this relay is held inside for some time and then comes out to give more voltage to the supply reel, to this motor, to give a little bit more torque just at the beginning, so that this won't happen. But I think this is adjusted for a normal speed machine, but for a high speed there should be some adjustment maybe. I don't know, maybe I should just make this capacitor a little bit more, with a little bit more capacity or whatever, but it's a minor problem. I won't bother for it now. That's it. For me, it works okay, and I will now close the machine and do a full test of it closed. There it is, the Revox finally assembled. I will now test it. This is the old motor, which is the normal speed one, and this one is also old, but I bought it only to convert it. It's a good thing that this modification can be reversible if you just take out that motor and put this one instead. It's not so easily reversible as it was the bulky one that I had on my other video, but it is reversible and that is a good thing. And now let's go and test it. Here it is. It is now finished and assembled, as you can see here. I did some calibration on the electronics, not changing any electronic components, but only messing a little bit with the trimmers to make it a little bit less responsive to high frequencies, because it is now much more responsive due to the increase in speed. Let's see how it works. By using this, I can increase the high frequencies if I want, but for 15 inches per second I have it the bare minimum, because this is the correct equal response, but that's how it works. I think it works, okay, I wouldn't say perfect, it's a modification, but I would call it pretty good for house use, okay? A professional would want a more professional job, certainly, but for my needs, I think this is more than enough. Okay, bye-bye. Thank you.